Unit 3, Lesson 3 test. Number 1. This states that matter cannot be created nor destroyed. A. Law of conservation of energy. B. Law of conservation of mass. C. Law of universal gravitation. Number 2. Which process is an example of a physical change? A. Carrots are cut into small pieces and mixed into a salad. B. A peanut butter sandwich is eaten and broken down by the acid in the stomach. C. Sodium metal and chlorine gas are combined to form a new substance, table salt. Number 3. Marco tears a piece of notebook paper into smaller pieces, as shown below. Tearing paper into pieces is an example of what kind of change? A. A change in mass. B. A physical change. C. A chemical change. Number 4. There are several differences between chemical and physical changes. Which process is an example of a chemical change? A. Steam rising from a boiling pot of soup. B. A metal railing rusting in damp weather. C. Ice melting. Number 5. Which process is an example of a chemical change? A. An iron nail rusting. B. Water cooling down while you take a bath. C. A piece of metal being hammered into a thin sheet. Number 6. When paper is burned, the mass of the remaining ash is less than the mass of the original paper. Which statement best explains this result? A. The ash has less volume than the paper. B. Some of the matter is destroyed during the reaction. C. Some of the products of the reaction were given off as a gas. Number 7. Which process represents a chemical change? A. A lake freezing over into ice. B. A metal bar is rolled into a flat sheet. C. Vinegar bubbles when baking soda is added. Number 8. What type of change is involved in the water evaporating into steam? A. Physical change. B. Chemical change. C. Biological change. Number 9. Which process is an example of a chemical change? A. Burning wood. B. Dissolving salt in water. C. Breaking a glass bottle with a hammer. Number 10. Trini adds 10 grams of baking soda to 100 grams of vinegar. The mixture begins to bubble. When the bubbling stops, Trini finds the mass of the resulting mixture. She determines its mass is 105 grams. Why has the mass changed? Hint, step 1. Find the sum of the masses of the baking soda and the vinegar. Step 2. Compare that sum to the mass of the mixture. Step 3. Determine the cause of the difference. A. A gas was formed during the reaction and left the mixture. B. Baking soda evaporated during the experiment. C. Mixtures are always less massive than their parts. Number 11. Chemical changes result in new substances, but physical changes do not. Which process is an example of a chemical change? A. Chopping a tree. B. Cooking a steak. C. Heating a cup of water. Number 12. Marisol finds the total mass of a sample of baking soda, a balloon, and a glass container with vinegar in it. She adds the baking soda to the vinegar and immediately places the balloon over the mouth of the container. After the reaction is complete, she again finds the total mass of the system. Which statement is true about this investigation? A. Mass is gained during the reaction because chemical change is taking place. B. The mass does not change because chemical change observes the law of conservation of mass. C. Mass is lost during the reaction because the gas is less dense than the baking soda or the vinegar. Number 13. Rita wants to make some toast for breakfast, which she knows involves a chemical change to the bread. She puts a slice of bread in the toaster, but after 10 minutes she notices that the sides of the bread are black. What caused this chemical change to go too far? A. The type of bread. B. The size of the bread. C. An increase in temperature. Number 14. Which observation is a sign of a chemical change? A. A rotting potato gives off a bad smell. B. A melting block of ice leaves a large puddle. C. A cloud changes shape when blown by the wind. Number 15. In the laboratory, Austin is given a mixture of iron filings, sand, and salt. To separate the mixture, Austin uses a magnet, boiling water, and a filter. Which statement is true about the process Austin uses to separate this mixture? A. He uses only physical changes to separate the mixture's components. B. He uses only chemical changes to separate the mixture's components. C. He uses both physical and chemical changes to separate the mixture's components.